The LeetCode problem we are going to solve now is called assign cookies, and we can see that this one is the LeetCode easy problem, and also this is a very popular problem. The problem statement is quite straightforward, that we are an awesome parents who wants to give cookies to our kids. But the thing is, every single child that we have has a different preference on the size of the cookie, which means that at any given factor we can only give them one cookie, but on top of it we are given two arrays. First array is that what is the preference or greed of the child, so that is given by the array called G, and we are also given the total size of cookies that we have, and that is given by S. Now at any given moment we can only feed the child if the size of the cookie is going to be greater than the greed of the child, like greater than or equal to. So let's try to understand this with an example. Suppose we currently have three children, so and for each of the child we have different greeds. So let's say that the first child is okay with 1, second child is with 2, and third child with 3. And currently we only have two cookies, and the size of both cookies are just 1. Now in this case we can see that for this child 1, because that child has just greed of 1, you can feed a cookie of size 1, so that's fine. But for this child 2, the child 2 has a greed of 2, but we only have the remaining cookie with just one size, which means we cannot feed this child, or neither we can feed this child. So in this case we need to return 1, because we are only satisfying the greed of just one child. So this is the whole problem statement. Let's just learn one more example. Suppose the given greed is equal to 3 and 4, and the given size of the cookies are going to be 1, 2, 3, 4 and 5. So in this case we can see that we have bunch of different cookies, and we also have cookies of size 3 and 4, which means we can satisfy both the kids. So we need to return 2 as the answer, because we are satisfying 2 kids. So this is the whole approach of the problem. Now let's see that what is going to be the brute force approach. Well, brute force approach is quite straightforward. For given input based on the size and the given cookie size, for every single greed we can try to iterate over the given sizes array and see that if the cookie of that particular size exists or not. If it exists, then we can simply return true, or we can just say that we can fulfill the need of that child. If it does not exist, then we can simply return the other way around. Now this approach would work as expected, but the thing is, this is going to go into big O of n square time complexity, because for every single greed we will have to look into the sizes array, or vice versa. A better approach is that we can actually sort both the given input for greed and also for the sizes, and then we will only have the greed from smallest to the largest. So let's say that we can have an input like this, and we can have a sizes also ranging from smallest to largest. Let's say something like this. In this case we will just need to do the matching of 1 to 1 between both of them, and for any particular value of s of I, we need to check that if that value is greater than or equal to the current greed of that child. If that is the case, then we can say that we satisfied that child, so we can update the counter and move on to the next child, and also we can move on to the next cookie. If that is not the case, and we identified some scenario where let's say that the given size is actually lesser than the child we are trying to satisfy, so let's say the child is 1 and the cookie size is 3, in this case we will still remain at the same child, but we will update the cookie size, or go to the next counter in the cookie. So in either case we are always going to be updating the cookie counter, but we would not update the child counter if this condition does not satisfy. In the end, we only exit out of the loop in two conditions. The first condition is that either we run out of the greedy children or kids, or second condition, we run out of the total number of cookies. In either case, we simply check that where do we land in terms of child index, and that is going to be our answer. So this approach would work perfectly fine, and it is an acceptable solution in an interview that you can expect and solve so far. Now in the coding part, I'm going to show you the code for this approach, because this is a simpler approach, but we can also have a better approach where we can use a hash map to basically go over the frequency of cookies based on the given sizes array. So what we can do is we can have a size array, then we can iterate over all of the different sizes, so let's say 2 and 3. Then we can have a hash map, so inside the hash map we are going to add all of these sizes and their frequency. So currently we have a cookie of size 2 that is occurring once, and then we have a cookie of size 3 that is also occurring once. And now we will try to satisfy the kids. So the idea would be that, let's say that we are currently at child number 1, and the greed of this child is also 1. So we are going to go to our hash map and we will try to see that whether any cookies with value 1 exist. If it does not exist, we will also check for any cookie with value 2 exists, so on and so forth, as long as we find some value inside the hash map. So we identify that, yeah, there exists a cookie of size 2. So because it exists, we are going to reduce the frequency, so this would become 0, and if this becomes 0, we can delete it from here, and we can say that this child that we had was also satisfied. And now we will move on to the next child that has the cookie preference of 2, and once again we find out the size, and we are going to reduce the counter, and if our hash map becomes empty, then we can simply return the child counter. Or if our let's say, instead of that, if our like number of greedy kids becomes empty, then also we can return the child index. So this is a better optimal approach, but the thing is, this solution is not quite straightforward, and also it yields big O of n space complexity. So whenever you give this solution, your interviewers are going to say that, what if I don't want to use extra space? In that case, you will once again come back to the sorting solution. So let me just give you side by side comparison. For sorting, the time complexity is going to be big O of n log n, but the space complexity is also going to be big O of n log n, that, and this is to run the sorting algorithm. For the hash map approach, the time complexity is going to be big O of n, which is faster, but the space complexity is also going to be big O of n, which is greater. So you can pick and choose your solution, and also let me in the comments if you want to see coding for both approaches as well. Currently I'm only going to show you the coding for the sorting approach. The coding solution is quite straightforward. First, we are going to use the inbuilt method to sort both the kids array and the sizes array. Then we are going to have two variables to store the value of the current child index that we are iterating over and the current cookie index that we are iterating over. Next, the simple thing is, while either the length of child index is less than the length of the given greed, or the length of cookie index is less than the given total number of cookies, we simply need to check that if for the given current size index, if the size of the cookie is greater than the greed of the child, then we need to update the child index and move on to the next child, because we already satisfied the current child. If that is not the case, basically we need to go to the next cookie in either case, and eventually in the end we simply need to return the total number of child index, which means the total number of kids who got satisfied with the size of the cookie that they received. So this is an awesome solution. Let's try to run the code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs beautifully and beats good chunk of other solutions, which is pretty awesome. Now I know that there are ways to make this even faster, and we can use some other technique apart from using the n log n sorting techniques, but anyways, this is still a good solution.